everyone, welcome to The Explainer. So today we're diving into something that is literally rewiring how we learn, teach, and create knowledge. Artificial intelligence is everywhere in education right now, but the research suggests we might actually be looking at it all wrong. It's time to move beyond viewing AI as just a plug-and-play tool, like a fancy digital calculator. Instead, we're going to peel back the onion of AI to reveal its deepest, often hidden layers as a complex educational infrastructure.
Okay, here's our roadmap for this explainer. First up, AI as educational infrastructure. Then we'll hit the efficiency layer, designing pedagogical friction, the ideological cost, and finally, responsible AI integration. Part 1. AI as educational infrastructure, moving from isolated tools to entire ecosystems.
All right, let's dive right into this. The old way of thinking, it treated AI like a standalone tool. You know the drill. Open an app, do a specific task, close it. Boom, done. But here's the new reality we're living in. AI operates as foundational, integrated educational infrastructure. Generative AI, large language models, tutoring systems, they aren't just visiting the classroom anymore. They are actively mediating the entire learning process. They're analyzing behavior and giving real-time feedback. Honestly, they aren't just in the ecosystem, they are the ecosystem.
So to really wrap our heads around this infrastructure, the researchers laid out this incredible 3-layer framework, and it's going to guide our whole explainer today. Layer 1 is efficiency. This is your optimization, automation, crunching the analytics. Layer 2 is pedagogy. That's the actual learning process, the feedback cycles, self-regulated learning. And layer 3, this is the hidden one, ideology. This deals with the norms, the biases, and who actually holds the epistemic authority inside the AI itself. Now, as you can see here, these layers, they aren't just sitting in separate silos. They are totally co-constitutive, meaning they operate simultaneously in this continuous dynamic loop. Think of it like a giant puzzle. Efficiency enables new pedagogical practices, right? And those practices change how we use the tools. But the kicker is, both of those are shaped by the ideological norms already baked into the tech. You literally cannot tweak one layer without causing a ripple effect across the others. Moving on to part 2, the efficiency layer, the operational core.
Let's be real, the immediate operational wins here for institutions are just immense. I mean, we're talking about automated essay scoring that generates incredibly detailed feedback almost instantly. We've got the power to process massive volumes of learner data to spot trends in real time. Plus, intelligent tutoring systems can offer dynamic, scalable guidance to thousands of students at once. It's wild. And the big selling point? This level of automation is supposed to free up educators from all those routine tasks so they can actually focus on high-level mentoring.
But wait, here is the trap. And we really need to pause on this. Are we actually improving learning, or are we just optimizing for algorithmic vanity metrics? It is so incredibly easy to fall into this trap. We celebrate the vanity metrics, like, wow, faster grading times, higher completion rates, perfectly structured grammar. But if we lean too hard into this efficiency layer, we run headfirst into a massive risk, which is the de-skilling of our educators. If we let algorithms entirely replace human pedagogical judgment, well, we might just end up building a hyper-efficient system that speeds up task completion without deepening actual human comprehension.
That brings us to part 3, designing pedagogical friction, the absolute necessity of cognitive effort.
So, what happens when AI gets a little too helpful? We run into this very real, very documented risk of cognitive offloading and metacognitive laziness. The research is super clear here. If students lean heavily on AI to just generate the answers, like letting a large language model write a whole outline or instantly fix their grammar without ever explaining why, they're essentially outsourcing their brain power. They externalize the cognitive effort. And sure, maybe their short-term performance looks fantastic on paper, but their long-term retention and independent problem-solving skills, those take a massive hit.
So how do we fix this? We have to deliberately design what's called friction into our AI-supported workflows. Because, let's face it, real learning demands cognitive effort. Instead of the AI just spitting out the final answer, a healthy pedagogical layer actually looks like this. Step 1, the student creates a draft. Step 2, the AI jumps in with continuous feedback. But then comes step 3, and this is the magic part: critical revision. This is the engineered friction. The student has to actively evaluate the AI suggestions, figure out what to accept or reject, and most importantly, understand why. That little bit of struggle, that iterative cycle, that is where the actual learning happens.
Section 4, the ideological cost. Let's talk about norms, bias, and epistemic authority. AI systems inevitably encode particular epistemic and cultural assumptions about knowledge, language, and learning. I want that to sink in for a second because it's a powerful quote straight from the research. It delivers a real punch. We have to accept that AI is never, ever just a neutral tool. Because these systems are trained on massive data sets created by humans, they are actively shaping what we consider to be valid knowledge in the classroom. Now, what's really fascinating, and maybe a bit unsettling, is the actual ideological cost of this helpful technology. Think about automated essay scoring. It operationalizes quality based heavily on dominant English conventions. And what happens? That inherently marginalizes diverse linguistic expressions and different cultural writing styles. Plus, when an AI spits out a fluent, super confident answer, students usually just accept it without batting an eye. This subtly shifts the epistemic authority, the ultimate decider of what is true and correct, away from human teachers and directly over to the algorithms. It's literally reproducing hidden biases without us even realizing it. Finally, Section 5, Responsible AI Integration, some guiding principles.
All right, so how do we ensure we're building an inclusive infrastructure and not just a highly efficient one? The researchers lay out some fantastic core design principles here. First up is transparency. AI systems absolutely must explain why they generated specific feedback so students can actually evaluate it critically. Second, we have to maintain teacher mediation. Humans need to stay in the loop to interpret these algorithms and provide, actual contextual judgment. Third, we need to design assessments that emphasize reasoning, evaluating the critical thinking and argumentation process, not just grading the final output. And lastly, continuous monitoring for ideological bias to ensure things stay fair across all diverse learner populations.
So, the absolute crucial takeaway here is this. AI has to be designed and integrated as a collaborative support system. It is not, and should not be, a substitute for human cognition. We absolutely need robust human oversight to bridge that shiny, flashy efficiency layer with the much deeper pedagogical and ideological realities of today's classroom. I want to leave you with this final, somewhat provocative thought to chew on as we wrap up this explainer. As we weave these wildly complex algorithms deeper and deeper into our educational infrastructure, who really holds the epistemic authority in your digital classroom? Is it the student? Is it the educator? Or is it the algorithm? Understanding this three-layer framework is the very first step to making sure the answer stays human. Thank you so much for joining me to explore this fascinating research. Keep questioning the infrastructure around you, and I'll catch you next time.